We have reached a state of time where our decisions impact the future generations more importantly and more severely than ever before. All forms of energy sources have been increasingly consumed over the past decades and will continue to do so in the future. It is obvious that the issue of sustainability has become important in the design of our technologies and processes. And the essential questions become, how can we meet this increasing demand and yet preserve the health of our planet? And where can we look for solutions? Because it certainly is our problem and our responsibility. I say, what better place to look into than the fundamental unit of life, the cell? Since the origin of life 3.6 billion years ago, according to the logic of Darwin's theory of natural selection, organisms have been selecting changes in cell features that provide a functional advantage to be passed on to future generations, while eliminating dysfunctional features. Therefore, you can imagine that over millions of billions of years of evolution and gradual evolution, that these cells have mastered efficient and sustainable processes on a microscale. So why not focus on the cell for these answers? At the basis of life, where molecules and cells run the show, microscopic technology has discovered circuits, assembly instructions, and machines, molecular machines, literally. There are machines which act as molecular trucks, machines that capture energy from sunlight, and machines that operate through feedback control. Do any of these sound familiar? Advancements in microscopy can allow us to dig in and study the details of the efficiencies of these micro mechanisms. So we have the technology. All we need is a little bit of trust in Mother Nature and the cooperation of biologists, molecular biologists, scientists, economists, and engineers in order to study the cell world for potential ideas and concepts that can be mimicked or applied on a larger scale in our world to improve our sustainability in our technologies and processes. I want to talk about one particular example of a miniature scale biological machine which caught my attention, the bacterium flagellum. From electron micrographs, we were able to identify that this organism contains parts that parallel the parts of an electric motor, with a propeller, a drive shaft, even a stator, and a rotor. The flagellum motor consists of a system of intricately arranged components which only function if all the parts are assembled in the correct fashion. The propeller can turn at 100,000 RPM, and some even say this machine is the most efficient assembly of a motor. Another example of biological machines is in the process of manufacturing of proteins, which involves machines that unwind the DNA and copy instructions to form messenger RNA. This RNA strand then enters a two-part molecular factory called the ribosome, where the process of transcription occurs. This transcription process is essentially the same as an assembly line, where amino acids are being manufactured to form the final product, which is the protein. The example of bacterium flagellum illustrates similarity between microbiological machines and our machines. And the protein manufacturing example is analogous to the process involved in manufacturing cars on an assembly line. In some cases, these applications may not seem as obvious, but then again, we know very little about life forms on Earth, and we know even less about the micro worlds of these organisms. Yet we still invest in billions of dollars to explore extraterrestrial worlds. The question is, are we willing to invest in further researching and discovering these diverse worlds? Because our investment can be paradigm shifting, or it can be a waste of time. Just think about it. Thank you very much.